Alright, today we're going to be talking about segments, midpoints, and bisectors. The midpoint of a segment is a point on a segment that is equidistant from both endpoints. And equidistant just means an equal distance. So down here we have line segment PQ. And I know that point M is the midpoint of that line segment. Now I don't just think it's the midpoint because it looks like it's in the middle. I know it's right in the middle based on the information that was given to me in this picture. These marks right here are called tick marks or congruency marks. And this one is marking line segment PM, and this one is marking line segment MQ. And so those markings tell me those two segments are congruent. And congruent means they have equal measures, so they're the same length. So that means that the distance from M to P is the same as the distance from M to Q. So this point is equidistant from the two endpoints. That makes it the midpoint. It is right in the middle. So a point is the midpoint of a segment if it is equidistant. The point is the midpoint of a segment if it is equidistant from the two endpoints. This means the distance from this point to each endpoint are congruent. Alright, you can find the midpoint of a segment that is either on a number line or coordinate plane. So when you're in a number line, you're just dealing with one dimension. When you're in a coordinate plane, you're dealing with two dimensions. A midpoint is right in the middle. Therefore, its coordinates will always be the average of the coordinates of the endpoint. So if you want to find the midpoint, just find the average or mean of the coordinates of the endpoints. So to find the midpoint, you just find the average or the mean of the coordinates of the endpoints. Now, if you don't know what an average is, let's just say I wanted to average or find the mean of the number 8 and the number 22. We have those two numbers. When we find the average or mean of something, we just add up all the numbers we have, and we divide by the number of numbers we added together. So I would add 8 and 22 together, and because there's only two numbers being added together, after I add them together, I'm just going to divide by 2. So 8 plus 22 is 30, and 30 divided by 2 is 15. So 15 is the average or the mean for those two numbers. If I have more numbers, let's say I got the numbers 12, 18, 6, and 24. Just made up 4 numbers. There's 4 numbers. I want to find the average or mean of those numbers. I would add them all up, and since there's 4 numbers I'm adding together, I would divide by 4. So I would just I would add them all up, and I would divide by 4. So if I add all those together, I got 12 plus 18 plus 6 plus 24. That would give me 60. And then after I've added them all together, I need to do the division. And it just so happens with the numbers I created that we will end up with the same average for these numbers as we had for the previous set of numbers. So that's how we find a mean or an average. That's all we're really going to be doing as we're finding the coordinates of the midpoints. So let's come down to example 1. It says find the coordinate of the midpoint of line segment FG. So here's F, here's G. So here's our line segment FG. We want to find the midpoint. Well, all I need to do is take the coordinates of the two endpoints and average them together. So I'm going to add -3 and 3 together. And since I'm adding two numbers, I would divide by 2. Well, -3 plus 3 is 0, and 0 divided by 2 is 0. So I know the midpoint would be at the point 0. Here's where the midpoint would be. And the midpoint doesn't always have to be named M, but if they have not given me a name for that point, M is the most commonly used name for it. Alright, let's try example 2. Find the coordinates of the midpoint of line segment AB. So we look down here. Here's point A, here's point B. Now it's obvious that point B has a coordinate of 3. A is maybe a little less obvious for some people. It is at the halfway mark between -3 and -4, so that makes it -3.5 or -3.5. So I need to average these two coordinates. So we got -3.5 and 3. We need to add them together. And since we're adding two numbers together, we will divide by 2. So -3.5 plus 3 is a -0.5. And then -0.5 divided by 2 is a -0.25. So that is where we will find the midpoint. So -0.5 is here. -0.25 would be halfway between the 0 and the -0.5. So right there, that's where our midpoint would be. Alright, let's try a slightly different situation. It says in example 3, if the coordinate of the midpoint of segment AB on a number line is 3, and A is at -2, find the coordinate of B. So we have line segment AB. So if I set up line segment AB, that means one endpoint is A and one endpoint is B. Now it says the coordinate of the midpoint is 3. The coordinate of the midpoint is 3. So I'm going to make this the midpoint. I'm going to show it's the midpoint by marking these congruent. And the coordinate is 3. It also says that A is at -2. And our goal is to find out what is the coordinate of point B. I don't know what the coordinate of point B is. Well, let's try this out. If M is the average of these two, it's halfway between them. Remember, this distance is the same as this distance. So what I'm going to do is just find out what's this distance. From here to here, what is the change in the coordinate? It's going from -2 to 3. So just think, is that an increase or a decrease? Well, it's an increase. It made it bigger, right? Well, how much bigger? We added 5. -2 plus 5 is 3. So that this line segment right here has a length of 5. Well, if this line segment has a length of 5, this one should have a length of 5 as well, right? So if from here to here I needed to add 5, then from here to here I will again add 5. So if I start at 3 and I add 5, 3 plus 5 is 8. So I know that that coordinate for that endpoint B is 8. Now if you need to check your work at the end just to make sure you're good, you can. You can go back now that we have both endpoints and you can test that out. And let's find the average of those two. If I add these two together, I'm adding two numbers together, so I divide by 2. A -2 plus 8 is 6, and 6 divided by 2 is 3. So that gives me the correct midpoint. So I know that I'm good. I know that I found the correct coordinate for point B. Alright, so that was finding midpoints on one dimension, on a number line. Now we're going to talk about finding midpoint on a coordinate plane. So now we're in 2 dimensions. So when we're in 2 dimensions, our coordinates look like this. They're an ordered pair where the first number is the x value and the second number is the y value. We are really doing the exact same thing, but because we have 2 dimensions, we have an x coordinate and a y coordinate, we are repeating this process twice. Now your answer should look like one of these. It should be an ordered pair. You should have an x coordinate and you should have a y coordinate. So I'm going to write what we should do right here to find the x coordinate, and I'm going to write right here what we should do to find the y coordinate. So for the x coordinate, we want to find the average of the x coordinates of the endpoints. And then to find the y coordinate, we want to find the average of the y coordinates from the endpoints. So you're really not doing anything different. You're just having to repeat the process twice. You're averaging the x coordinates and you're averaging the y coordinates from the endpoints, and those will give you the x and y coordinates for the midpoint. Same thing we just did You're just repeating the process twice. So right down here says find the midpoint between the point negative 11, 3 and the point 8, negative 7. So remember that first number is the x, second number is the y. First number is x, second number is y. I'm just going to average the x coordinates right now. So I'm going to take negative 11 and 8. Now if I'm averaging them, remember I need to add them together. And since I'm adding two numbers together, I will divide by 2. So negative 11 plus 8 is a negative 3. And if you like fractions, your fraction is reduced right there already because 2 doesn't go into negative 3 evenly. Or if you like decimals, that could come out to a negative 1.5. I do the same thing with the y values now. I'm going to average the y coordinates from the endpoints. So I have 3 and negative 7. When you add a negative number, you're really subtracting. So we're doing 3 minus 7 is a negative 4. Then we divide it by 2, gives us a negative 2. So we found the x coordinate for the midpoint when we averaged the x coordinates from the endpoints. And we found the y coordinate for the midpoint when we averaged the y coordinates from the endpoints. So there is our midpoint. All right, let's try example 5. Same process. Find the coordinates of the midpoint of line segment VW if V is at the point 3, negative 6 and W is at 7, 2. Let's start with the x coordinates, the 3 and the x. We're just going to average those two numbers. So we add them together. And there's two numbers, so we're dividing by 2. 3 plus 7 is 10, and 10 divided by 2 is 5. There's our x coordinate for the midpoint. Let's do the same thing for the y's. The y values are negative 6 and 2. So I take negative 6 and 2, I'm adding them together, dividing by 2. Just averaging them, finding the mean. So negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. So there's the y coordinate. So when I write my answer, the x coordinate is 5 and the y coordinate is negative 2. And that is where you will find the midpoint for line segment VW. All right, let's try something a little different. On the last two problems, we've had both of the endpoints, and we've been looking for the midpoint. On example 6, we're going to have the midpoint and one endpoint, and we're looking for the other endpoint. Kind of like we did on example 3 earlier, when we were still dealing with one dimension, but now we're doing it with 2 dimensions. So you could take the time to plot this on a graph if you would like to have a better visual, but that takes more time. So if you got one handy and it's easy to do, then you can do that. I'm not going to worry about that. It says M is the midpoint of line segment AB, with A at the coordinates 0, 1 and M at the coordinates 3, 5. And we want to find the coordinates of line segment B. So we have line segment AB. We know the coordinates of A are 0, 1. We don't know the coordinates of B. That's what we're trying to find. But we also know the coordinates of M, the midpoint, are 3, 5. And I know M is the midpoint, so I'm going to mark those congruent right there. All right, I'm going to do just like what we did on example 3 earlier, but I'm going to repeat the process twice. Remember that this is a straight line segment. So just imagine traveling from this end to this end. M is at the midpoint, so it's exactly halfway from here to the other end. So whatever I do traveling from here to here, I should be able to do the exact same thing to get from here to here. So let's see what happens. As I go from here to here, what happens to the x value? It goes from 0 to 3. Well, that's an increase of 3. Well, if the x value increases by 3 from here to here, it should do the exact same thing from here to here because it's the same distance and in the same direction. So I'm just going to add 3 more. So 3 plus 3 is 6. There's the x coordinate. Now I just repeat that exact same process with the y values. So for y, from 1 to 5, that's an increase of 4. So if it goes up by 4 from here to here, it should go up by 4 from here to here. So I'm just going to increase it 4 more. So I'm going to take 5 plus 4 is 9. And I know the coordinates of B are at the coordinates 6, 9. Okay, let's talk about a segment bisector. A segment bisector is a point, line, ray, segment, or plane that intersects a segment at its midpoint. The word bisect basically just means to split into two congruent halves. So if you want to split something into congruent parts, you would cut it right through the middle. So if something is intersecting a segment at its midpoint, it is going to bisect it, split it into two congruent parts. So we're going to use this picture for these three examples, and it tells you right here that line segment WY bisects line segment UV at point Y. So what that tells me is that line segment WY, that is the segment bisector, and the segment bisector is like the axe or the saw or the scissors or whatever. It's the thing that's doing the cutting. It is cutting this segment into two congruent parts. It's taking line segment UV and it's splitting it right through the middle into two congruent parts, which means that point Y is the midpoint. Alright, so after having gotten this piece of information, let's try example 7. It says if the distance from U to Y is equal to 5, from U to Y is equal to 5, then find the distance from Y to V. We want to know, what is this right here? Well, we just finished saying that this segment was being bisected, split into two congruent parts, which is why I marked these congruent. So if this segment is 5, this segment should also be 5. So we'd say the distance from Y to V equals 5. So I know that that's 5 now. The other part of that question was we're supposed to find the distance from U to V. So from U to V, well, I would have 5 and 5. So together that entire segment has a length of 10. I'm just adding 5 plus 5 to get 10. Alright. Okay, I'm going to erase those numbers real quick so we can do the next problem with the same picture. And let's look at example 8. If the distance from U to Y is 4x minus 3, and the distance from Y to V equals x, find the distance from U to Y and the distance from U to V. Now before I can find the length of any segments, I would need to figure out what x is. Because right now I don't know the length of any segments. Well, just like on the last problem, I already know that these two segments are congruent. They have equal measures. So because of that, I'm going to set up an equation that I can solve here. I know that this and this should be the same thing, the same amount. So I'm going to say 4x minus 3 equals x. Anytime I know two things are congruent, I can just set them equal to each other. Because that's what it means. Congruent means equal measures. So now I'm just solving this equation. So don't want x on both sides. I'm going to subtract x. It leaves me with nothing on this side. Nothing is 0, so I hold that place with 0. I want to try to start getting x by itself. I'm going to start by getting rid of the constant. Anything I do on one side, I got to do it to the other side. 0 plus 3 is 3. I'm going to rewrite it over here because I'm run out of room down there. And the next step, x is being multiplied by 3, so I'm going to divide by 3. That'll give me x all by itself. Got to do the same thing to the other side of the equation. 3 divided by 3 is 1. So now that I know what x is, we can substitute that back in and find out what these segments are. So the distance from U to Y, that was the one with the expression 4x minus 3. So the distance from U to Y is 4x minus 3. Now that I know x is 1, I can substitute that 1 in place of x. And then I can solve. So 4 times 1 is 4, and 4 minus 3 is 1. So the distance from U to Y is equal to 1. Then I'm also supposed to find the distance from U to V. Well, we just finished figuring out that the distance from U to Y is equal to 1. And we already know x is 1, right? So this has a length of 1. So if both of these segments have a length of 1, what would the distance be from U to V? we're just adding 1 plus 1, and that whole thing would have a length of 2. So the distance from U to V is equal to 2. Alright, one more problem. So I'm going to again erase these numbers. And on example 9, it says if the distance from U to V equals 18, find the distance from Y to V. So the distance from U to V, now U to V, that is this whole thing, and it said it is 18. If that whole thing has a length of 18, we want to know what is the distance from Y to V. Okay, well remember this segment, line segment UV, is being bisected. It's getting split into two congruent halves. So each one of these parts, because they're congruent, they should each be half of that whole thing. So what is half of 18? It's 9. So I know the distance from U to Y is 9, and I know the distance from Y to V is also 9. Because 9 plus 9 equals 18. They're each half of that whole thing. So the distance from Y to V equals 9.